Hello everybody and welcome back to my channel. So in today's video we will be seeing how do we calculate time complexity for recursive functions. So before starting with the video, to all the people who like my videos and they see my videos but they do not subscribe to my channel, so please don't do that and just subscribe to the channel. Also, if you want any short notes regarding all the videos that I make, so I upload short notes on my Instagram handle, so you can go and follow me over there. In case if you want me to solve any particular question of yours or any algorithm or any doubt you have, then just leave it in the comment section below with hashtag #CodeMyQuestion. Now let's start with today's video. Now, in the previous video, we saw how we can calculate time complexity for basic for loops and loops which call functions. So, in today's video, we will be seeing how do we calculate time complexity for recursive functions. Now, for recursive functions, what we do is we write recurrence relations, and using these recurrence relations, we find the actual time complexity in the value of n, where n is the number of inputs that we take. Now, see, recurrence relation can be written for anything. That is, you can write recurrence relation for the amount of time a function requires, or you can also write the recurrence relation for the number of swaps done by a particular function. Also, you can write recurrence relation for the number of additions or subtractions or anything. So, in today's video, we will be seeing how do we write it for time. Now, we can solve recurrence relation using various methods. In the upcoming videos, we'll be talking about those methods. So today, let's first see how do we write recurrence relation. So now let's suppose I say that this function takes a total of tn times. I'm saying it over here as n because I am taking the input over here as n. So this doesn't need to be, this variable doesn't need to be n necessarily. It could be a also, or over here also I can take any variable of my choice. So over here I'm taking it as tn. So I have to calculate how much time this tn basically takes. So now we know that we have main two parts in a recursive function. First is our base case. So base case is that part of a recursive function which doesn't have a recursive call. So over here this is our base case, and this is the reason why my function or my recursive call terminates. And in the other part we have some other functions as well as our recursive function or the call to the recursive function. So our base over here we just have one base case. We can have multiple base cases as well. So here I'll be just writing it for this. So first of all, we know that when my base case, which is n is equals to 0 or 1, so I am just simply returning 1. So this return statement takes time of order of 1 or a constant time, and this is when my value of n is 0 or 1. So over here what I'll write is the time taken by my function is of order of 1 if the value of n is 0 or it is 1. Now let's see for the rest half. Now see, if we come to this part, so first we are calling this function. This function again, which is a recursive call. But over here the value of n comes to be or decreases to be n by 2. So over here what we can write is we have n by 2. So tn by 2 is some amount of work. Now plus this part, because first we are calling this and then we are calling this. So this is going to take the time of tn by 2, and similarly we will also take tn by 2 time. So we'll have another tn by 2 over here, which is because of the second recursive call. The next thing is the return statement. So this takes time of order of 1. So we write plus order of 1. And this is for any other value but 0 or 1. So this is the recurrence relation for the time of this particular function. Now let's talk about this function. See, this is more or less the same. First of all, we'll just take it as tn. Now, talking about the base case, it returns 1, so it is order of 1 for these two values. So I say that my Tn is of order of 1 when my n is equals to 0 or 1. Next, talking about these two. So we just have one recursive call over here. So I say that this particular takes the time of t n by 2, and after this statement we come over here and this takes time of order of 1. So this is the amount of time it takes for values of n other than 0 and 1. Now let's talk about this. Similarly, the base case over here will be the same, which is it takes order of 1 for values of n with 0 and 1. And let's see the other part. See, first of all, we are having a recursive call with the value of n as 2n by 3. So over here we'll have t 2n by 3 plus we have another recursive call which has the value n by 3. So we'll have n by 3 over here, tn by 3. The last statement is a return statement which simply takes order of 1 time. So we'll have plus order of 1, and this is for any other value but 0 and 1. Okay, so coming to the next example, over here we can see that in my base case, instead of returning just a 1, we have a function. Now let's suppose this function takes a time of order of n. So what we say is that when we encounter the base case, which is when my n is 0 or 1, so the time it takes is of order of n. Now let's see how much these two take. Now A takes the time of n by 3 as it is a recursive call. Next we have B. It takes time of n by 4, and then this takes order of 1 time, so plus order of 1. So this work is being done for any other value than 0 and 1. Now in this one, similarly over here we have some function which takes order of, let's suppose it to be n square time. So the value of our Tn will be that once it hits the base case, so it takes the time of n square for the values of 0 and 1 or 1, and other than that we have a recursive call of n by 3 length, plus over here we are calling a function. Now this function takes the time of order of n, so I'll add order of n over here. So this is for any other value but 0 and 1. Okay, now let's talk about this one. So over here our base case is simply working in order of 1. So we'll have order of 1 for the values 0 and 1. And then we have a recursive call. So over here we have tn by 3 plus this function takes time of n square log n. So I'll write n square log n. You can write it order of n square log n or big O of n square log n also. Both are the same. And this is the value of our tn. Now let's see this one. Now suppose this takes a time of nq. This takes order of 1 time, and this takes, first is the recursive call which is tn by 3 plus nq plus order of 1, which is for the return statement. If you even don't write it, then there is no issue, but it is a good practice that you write everything. This is for all other values of n, and the order of 1 for 0 and 1. So this is our recurrence relation for time for this particular function. So this is how you write recurrence relation for recursive functions. Now in order to get the time complexity, exact time complexity, we solve these recurrence relations. So in the upcoming videos, we'll be talking about various methods using which we can solve these recurrence relations. So this was all for today's video. If you like my video, then do subscribe to my channel. Also like the video and also share it across with your friends. Thank you.